Hey everybody, this is where we left off with our 30S Chapter 3 Quadratic Functions unit, and we've just finished up Lesson 2. Oh, my cat has decided to come over. Hey kitty. I don't know if you can hear that or not, but he's meowing at me and I don't know why. Anyway, this is where we left off, and I said you should try this sheet on your own. So let's just quickly summarize everything you were supposed to learn from the last lesson. First of all, the a number, that is the coefficient on the x squared term in a quadratic function, is what we call the vertical stretch. If a is greater than 1, as in it's a whole number, there is a vertical stretch by a factor of a, and this would make the graph, I use the word narrower, than the graph of y equals x squared. If a is between 0 and 1, then there is a vertical compression, and this would make the graph wider. Instead of a vertical compression, you could also consider that a horizontal stretch. Examples of vertical stretches would be these, and of course it doesn't mention it here, but for this column here, if a is negative, the parabola opens downward. Okay, and then for number 2 here, the vertical shift, if there is a k that's greater than 0, as in it's positive, there is a vertical shift up k units. If k is less than 0, there is a vertical shift down k units, so if you have a negative. And there's 2 examples. For horizontal shift, if h is greater than 0, there is a horizontal shift of h units to the right. And if h is less than 0, there is a horizontal shift of h units to the left. But watch out for what this h number actually means. Remember, this negative, or this subtract, is not part of what the number h is. So for example, x minus 3 squared, don't think of this as a negative 3. Think of it as minus a positive 3. So in fact, that's shifting to the right. Don't think of this as add 2. Think of it as minus a negative 2. So it is in fact 2 units to the left. So that was the gist of our last lesson. Today we're going to move into 3.2 and back into standard form. And standard form tells us, well, the direction of opening, the basic shape of the graph. As long as a is not equal to 0, then we know that we have an ax squared makes a quadratic. As long as a is positive, we know that we are opening upward. And c tells us the y-intercept. B influences the positioning of the graph. We'll get more into that in a bit. And here's an interesting new formula for you. I think we probably have this on the formula sheet. If we don't, we'll add it before we do the next test. But this little formula can tell us the x value of the vertex if the equation for the quadratic is in standard form. So, first things first, what if we're in vertex form and we would like to get to standard form? Well, that's just a matter of some algebra. So let's run through a little bit of algebra here. We're going to expand this. So, expanding means we follow the rules of BEDMAS. And we first of all get rid of that squared. So f of x would equal 1/4 times x squared minus 4x plus 4, and then minus a 3. F of x, and this is what I'm dealing with. I'm trying to do this video, and I have company. What are you doing on the desk? Crazy cat. Okay, so if we get interrupted, I apologize. Anyway, moving along here. 1/4 of x squared minus, I'm just distributing that. That'd be x plus 1 minus 3. And finally, that's going to lead me to f of x. Final answer is equal to 1/4 x squared minus x minus 2. And there we go. We have an a number, a b number of -1, and a c number of -2. We are in standard form. Unlike standard form for a linear, we actually don't care that this is fractional. In fact, there's really nothing you could do to make it not a fraction unless you wanted to times this side of the equation by 4 and have a 4 hanging around over here, which we don't. We want y, or f of x, equals a, b, c. And we don't care if a, b, and c are anything short of just being real numbers. All right, what are the advantages of each form? Well, the advantage of vertex form is it tells us the vertex. But standard form has some advantages as well. And it's not that hard to find the x value of the vertex. Again, this little formula gets it for you. And you'd find the y value. It says, how would you find the y value? Well, you'd find that by substitution. And I'll show you that in a sec. Let's use an example here. Suppose we wanted to find the y-intercept of this. So we have a quadratic equation. Well, the y-intercept is easy. That's when x is 0, which it'll just be this constant of -5. Now, x-intercepts I'm going to have to get by perhaps factoring. What two numbers times to make -5 and add to make +4? And if you're still struggling with that, that's something you absolutely have to practice. You can't get through this stuff without being able to factor. So that means that of course, my x-intercept happens when y is 0. I meant to write a 0 there. So if y is 0, and that's the factored form of this quadratic, I could say x is -5 and x is 1. Axis of symmetry. Well, to get the axis of symmetry, I'm first of all going to have to find the vertex. So I probably should have these in a different order. I'll do this first, and I'm going to find the vertex by using the formula x equals -b over 2a. So x is equal to -4, right? This is the a number is here, the b number is here, and the c number is here. So -4 over 2 times 1, because think about it, the number in front of x squared is 1. So the x coordinate of the vertex is -4 over 2, which is -2. Now I'm going to substitute that x in there to find the y coordinate. So this is what I meant by we're going to find it by substitution. So that's going to be y is equal to -2x squared plus 4 times -2 minus 5. So that y coordinate, they don't really give me enough room there, is 4 minus 8. Remember that negative gets squared, so it's gone. 4 minus 8 minus 5. So 4 minus 8 is -4. -4 minus 5 is -9. So therefore, my vertex is x is -2, y is -9, and my axis of symmetry then is x equals -2. Just for fun, let's check that out on Desmos and make sure we got all that right. So for Desmos, I'm going to just enter that as y equals x squared plus 4x minus 5. And let's see. We'll have to zoom out a little to see it. But our x-intercepts are -5 and 1. Check. Our y-intercept is -5. Check. And our vertex should be -2, -9. Check. So there we have it. Okay, moving on. This guy. My y-intercept is -6. My x-intercepts are, set that to 0 and factor. What two numbers times to make -6 add to make -5? That's -6 and +1. So that means my x-intercepts are -6. Oh, sorry. +6. What am I saying? +6 and -1. My axis of symmetry, I'll tell you that after I find the vertex. So let's use the formula again. X is -b over 2a. And let's see. So -b over 2a is going to be the negative of -5, which is 5, over 2 times 1. This one's going to be a fraction. So the x value is 5 halves. I'm going to plug 5 halves into y, or into x to solve for y. Sorry, I'm off the screen. I'm going to put 5 halves into x to solve for y. So this is 5 halves squared. And now we have cat interference. Hi, cat. His name's Marmalade. He's now trying to eat the camera. Yeah, you can't. Okay. You be good. -5 times 5 halves. -6. Okay. Fraction time. If I square 5 halves, I get 25 fourths. 5 times 5 is 25 halves. -6. little bit of common denominator here would be 4. So 25 fourths minus 50 fourths minus 24 fourths. 25 minus 50 is negative 25. Negative 25 minus 24 is negative 49 fourths. At least I think that's what it is. I'm being distracted again by okay, leave that. Ah, my pencil. Okay, listen, you. Okay, you gotta go down. I'm sorry, I can't make a video with you being like that. Okay, sorry about that, everybody. There. All right, let me just double check my fractions. I was being distracted there. 25 minus 50 is negative 25. Negative 25 minus 24, yep, negative 49 fourths. So my vertex should be 5 halves, negative 25 fourths. So that would mean my axis of symmetry is x equals 5 halves. Let's go see if all those numbers are right. 2 desmos. So y equals x squared minus 5x minus 6. And let's see. My x-intercept should be negative 1 and 6. Check. My y-intercept should be negative 6. Check. And my vertex is not going to be a whole number. It's going to be this weird fractiony number. And yep, they give it to me in decimals, 2.5, which is 5 halves, and negative 25 quarters, which is 4 goes, yep, negative 12 and a quarter? Hang on, something might be wrong with my answer here. 25 over 4 is not 12. Let's just double check. Maybe I did get lost in my fraction here a little bit. 5 squared is 25. 2 squared is 4. 5 times 5 is 25. Did I put this in the right place? X squared. X is 5 halves. I square 5 halves. I get 25 fourths. I put in 5 halves here. I get negative 25 halves. And there we go. Yes, I did make a mistake. Oh, wait a minute. No, I didn't. Did I? 25 over 2, if I have to change that to fourths, is 50 over 4. 6 over 1 is 24 over 4. 25 minus 50 is negative 25. Negative 25 minus 4. Oh, yeah, I did. I have the answer here, and I copied it wrong. Whoops. This should be 49 fourths, which is totally 100%, yes, 12 and a quarter, because 4 goes into 49. Yes, Kitty, thank you. 4 goes into 49 12 times with 1 quarter left over. There you go. Okay, so there we go. Vertex form. Or sorry, standard form. But I found my vertex. All right, next. There's one more form to look at. This is called factored form. And the factored form tells us the actual x-intercepts, right? Vertex form told us the vertex. Standard form doesn't tell us that much. Tells us the y-intercept, I guess. But factored form actually tells us what x1 and x2 are, which are the x-intercepts. So for example 8, a graph of a quadratic goes through 316, and we are going to figure out the equation of the graph in standard form, but we're going to use factored form to get there. So it has zeros at 1 and 7. So that means that it has factors. So zeros at 1 and 7 means factors of x minus 1 and x minus 7. So the zeros of the function are the x-intercepts of the graph, so it must look like this. So it must look like y equals some number a, which I don't know yet, I'm going to figure that out, times x minus 1, there's x1, and x minus 7, there's x2. Does it matter what order those two things are in? No, not at all, right? Because you can multiply two things in any order. So now, we're going to substitute. X1 is, again, well, I kind of did that already. X1 is 1, X2 is 7, and that's the formula we come up with. A times x minus 1 times x minus 7. So the coordinates of B, 3 in there. Yeah, hi. Back again, are you? The coordinates of B, 3, 16 also make this a true equation, right? This point is on this line somewhere. So that means when x is 3, y is 16. So I know when x is 3, y is 16. So 16 goes here. A, I don't know yet. That's what I'm trying to figure out. And x is 3. Okay, do a little bit of math on that. 16 is equal to 3 minus 1 is 2. And 3 minus 7 is negative 4. So 16 is equal to 2 times negative 8. Divide both sides by negative 8. And my a value is negative 2. So in factored form, the equation is negative 2, the a value, times x minus 1, x minus 7. So there's the equation in factored form. Let me get the cursor out of the way. So in standard form, all I have to do now is expand this. So that's going to be x squared minus 8x plus 7. So y is equal to negative 2x squared plus 16x minus 14. And this is cat approved, as you can see. And just for fun, once again, I want to play with some Desmos. So that means you're going to have to get out of the way again, because I can't see the screen past your big fuzzy head. So let's go to Desmos, and we'll turn that one off. And first, we'll just enter the equation the way we had it in factored form. One of the great things about Desmos, and actually one of the advantages that Desmos has over the graphing calculators that some schools make pre-cal students buy, is that you can enter the equation in really any form you want in Desmos, and it'll figure it out. So I figured out that it was negative 2 times x minus 1, close bracket, times x minus 7. And yep, that's a parabola. Let me zoom out. And we said that this parabola should have the point 316 on it, right? Because it even said that in the question, that's how we figured out A. So let's see, is 316 on here? 316. Label it. Yep, looks like it is. It's right there on the line. And if I did my work right, I should be able to enter the answer that I got in standard form, and it should be the exact same equation. Negative 2x squared plus 16x minus 14. And look at that. It's black, it's green, it's black, it's green. It's the same line. Yay! So we must have done it right. Cool. So that's page 19. That's the factored form. Guess what we got to do now? Yep, word problems. A bridge spans a horizontal distance of 40 meters and it has a parabolic arch. I think that should, yeah, arc, whatever. 1 meter from the end of the bridge, the arch is 1.95 meters high. Determine an equation that represents this parabolic path, and then sketch the parabola with one end of the arch at the origin. So they've already done the sketch for me. That's very nice. And of course, the origin is, the point 0, 0. You should know that. The origin is 0, 0. And since the arch spans a horizontal distance of 40 meters, that means that the end of the arch should be the point 40, 0. So my x-intercepts are 0 and 40, right? It hits the x-axis at 0, it hits the x-axis at 40. So my equation is sum a times x minus 0 times x minus 40. I don't know what a is, but I know that x comma y can be 1 comma 1.95. Now if we give you a question like this, we are going to let you use a calculator. So I might have to go to a calculator. Let's see how it goes. When y is 1.95, x can be 1. 1 minus 0, 1 minus 40. So 1.95 is equal to a times 1 times negative 40. Divide both sides of the equation by negative 40. Yep, I'm going to need that calculator. I have no idea what 1.95 divided by 40 is. So let's see, we'll punch that. 1.95 divided by negative 40. Bada boom. And I Oh, there we go. That's a nice fraction answer, but I think most of you don't have a fancy calculator like this, so you'll get a decimal when you do this. So that's negative 0.04875. What did I say it was? 0.04875. So I'm ready for an equation now. My equation is, let me give myself some more room here. Y equals negative 0.04875 times x. I'm not going to write x minus 0 again. I'm just going to write x because minus 0 is kind of a, kind of a waste of characters, times x minus 40. So that's my factored form. If I wanted this not in factored form, I would have to multiply this out a bit. So that would be negative 0.04875. I said 5, and I wrote some sort of bizarre symbol that's not a 5. X squared, and then I'd have to times this times x times negative 40, which would be plus, well, let's just times that number by 40 and see what happens. Times 40. Oh yeah, I know what's going to happen. It'll actually be negative 1.95. So plus 1.95. Ta-da! So there we have it. There's our equation of this arch, assuming the arch is a parabola. Okay. Solution part B. All right, what was the part? Oh, there's a part B for this question. It says the center of the arch is, of course, at the vertex. The height of the arch is the y-coordinate at the vertex. I would like to know what that number is. The x-coordinate of the vertex is halfway between 0 and 40, which is, of course, 20. So going back to my picture, right here, this middle part here must have an x-coordinate of 20, but I'd like to know the y-coordinate. So how high, just go back to this for a sec, I want to know how high that is. How high does the arch go? So I'm going to use 20 into my equation here. So it was negative 0.04875, and x we just said is 20 times 20 squared. Oh, I just realized something. My bad. Sorry. I forgot my x on here, right? It was this number times x, which is that. Then this number times x times negative 40, which still has an x on it. So can you go back and fix your note there? Just realized I lost the x. Anyway, that would be plus 1.95. And again, x here is 20. And obviously I'm going to need a calculator for this. That's a little past my ability to do mental math right there. So negative 0.04875 times, I know 20 squared is 400, plus 1.95 times 20. Ba-da-boom. And that would be 19.5 meters. Therefore, the arch is 19.5 meters high. Okay, so there's one word problem. Let's do one more and we'll call it a day. Example 10, you would like to buy a rectangular fence to maximize the area inside. You have enough money for 160 meters of fencing. What are the dimensions of the fence that you build? Write a quadratic function in standard form to represent the area inside your fence. Okay, so let's draw a fence, shall we? It's a rectangular fence. Rectangular fence. And what do I know about it? Well, I know all four of these sides add up to 160, but I don't know how much bigger this side is than that one. I really don't know anything. So here's what I'm going to do. I'm going to call these widths x, right? It's a rectangle. The widths have to be the same. The lengths have to be the same. And that's going to make these two lines here. Well, if I've used x of fencing here and x of fencing here, I've used a total of 2x of fencing. So that would be 160 minus 2x of fencing left over to do these two lines. But again, these two lines have to be the same length, so I have to cut this amount in half. And that leaves me with 80 minus x meters of fencing. Now, what is it that I'd like to do? I would like to find how much x should be and how much 80 minus x should be so that I have the maximum amount of area possible. So my area is, of course, length times width. Let's make a quadratic out of that. So area is x times 80 minus x. Get it? Length times width. Putting that into a quadratic, a is equal to negative x squared plus 80x. I just multiplied that through and rearranged it a bit. And there it is. That's my equation in standard form. You might even want to say, hey, area as a function of x, ooh, let's get fancy and use function notation, is negative x squared plus 80x. And that is the area. Now, determine the vertex. So what's the vertex of this thing? Well, remember, we have a formula for vertex. The x-coordinate of the vertex is negative b over 2a. b here is 80 over 2 times negative 1, which is the negatives cancel, and 80 divided by 2 is 40. So the vertex is 40. And okay, so the vertex is x-coordinate is 40. Let's find the y-coordinate. So basically I want a of 40. To use function notation again. So that's negative 40 squared plus 80 times 40. I can probably do that without a calculator. Let's see. That's negative 1600. And 80 times 40 would actually be 1600 times another 2, because this is like 2 times 40 times 40, right? 2 times 80. 80 is 2 times 40, so 2 times 40 times 40. So that would be plus 3200, which is, of course, 1600. So my vertex is x was 40, and y, or a in this case, was 1600. And what it asked me, what does this represent? Well, that represents the width that will give me a maximum area. And this, of course, is the maximum area, because remember, the vertex is where the maximum is when I graph this thing. So there we go. There's an example of the types of word problems you're going to have to do in your assignments. Thanks for watching, everybody.